Hi my dear friends, welcome to Venus EduTech. In this video we are going to start a fresh topic called polynomials. Are you ready to study the new chapter? Yes? So let's get into the video. Friends, in class 9 we have studied polynomials in one variable and their degrees, right? And do you remember the term degree of the polynomial? P of x. What is degree of the polynomial? Do you remember this term, that is degree of the polynomial? P of x. That is, if P of x is a polynomial in x, that means if P of x is a polynomial in the variable x, then the highest power of x, then the highest power of x in P of x, then the highest power of x in P of x is called degree of the polynomial P of x, right? Is called degree of the polynomial that we studied in our lower class, right? Is called the degree of the polynomial P of x. So what is degree of the polynomial P of x? If P of x is a polynomial in the variable x, then the highest power of x in P of x is called the degree of the polynomial P of x. For example, 4x plus 2. 4x plus 2 is a polynomial in the variable x of degree 1, right? X means x raised to 1, right? So what we can write? 4x plus 2 is an example of a polynomial in the variable x. 4x plus 2 is a polynomial in the variable x of degree 1, right? And what about x square plus 5? X square plus 5 means x square plus 0x plus 5, right? So this is a polynomial in variable x of degree 2 because it is x square, so of degree 2. So degree means the highest power of x in P of x. The highest power of x is x square. So x square plus 5 is a polynomial in the variable x of degree 2, right? So these are the examples of degree of polynomial. And what about x cube plus 2x plus 6? This is an example of a polynomial in the variable x of degree 3, right? So degree of a polynomial you understood, right? That is, if P of x is a polynomial in the variable x, then the highest power of x in P of x is called the degree of the polynomial. And these are the examples. 4x plus 2. Here the degree of the polynomial is 1 because the highest power of x. Here the highest power of x is x raised to 1. So we can say that 4x plus 2 is an example of a polynomial in the variable x. In the variable x of degree. What is the degree? In the variable x of degree 1, right? And what about degree of this equation? 2y square minus 3y plus 4. This is also a polynomial. This is an example of a polynomial. Here the variable is y, right? So this is a polynomial in the variable y of degree. What is the degree? What is degree of a polynomial? It is the highest power of x or y in P of x or P of y, like that. Here the highest power of variable is y. So the highest power of y is square, right? So it is a polynomial in the variable y of degree 2. Because here y square and y raised to 1, which is the highest power, which is having the highest power y square or y raised to 1 y square. So it is a polynomial in the variable y of degree 2. And what about 5x cube minus 4x square plus x minus root 2? This is also an example of a polynomial in the variable, which is the variable here in this question. This is an example of a polynomial in the variable again x, right? Of degree. What is the degree here? Degree means the highest power of x in this equation, right? In this polynomial. So which is the highest power of x? X cube compared to x square and x, which is the highest power? X raised to 3, right? So of degree 3. Got it? Now what about this polynomial? 7u raised to 6 minus 3 by 2 u raised to 4 plus 4u square plus u minus 8. This is also an example of a polynomial. Here the variable is u, right? So it is a polynomial in the variable u of which degree? highest power of u here, it is u raised to 6. So this is a polynomial in the variable u of degree 6. Understood? The concept, that is the term degree of the polynomial, right? So degree of the polynomial is nothing but the highest power of x in that given polynomial. For x plus 2, the highest power is x. The highest power of x is 1. And what about this one? The variable is y. The highest power of y is 2. So degree is 2. And here x cube minus 4x square plus so and so. So here the variable is x. The highest power of x is 3. So the degree will be 3. And what about this polynomial? The variable is u and the highest power of u is u raised to 6. So degree will be 6. Understood? And expressions like 1 by x minus 1 root x plus 2, 1 by x square plus 2x plus 3. Expressions like these, root x plus 7 or 1 by x plus 4, like that. Expressions like this are not polynomials. They are not polynomials. Okay? Now friends, we can discuss what is linear polynomial, what is quadratic polynomial and what is cubic polynomial. Before that, you remember what is a degree of the polynomial, right? What is the degree of the polynomial? If p of x is a polynomial in the variable x, then the highest power of x in p of x is called the degree of the polynomial. And what about linear polynomial? A polynomial of degree 1, right? So a polynomial of degree 1 is called the linear polynomial. Write this in your notebook. A polynomial of degree 1 is called linear polynomial. And these are examples of linear polynomial. All these are given in our textbook. So read that. And these are examples of linear polynomials. 2x minus 3. This is a polynomial of degree 1, right? Root 3x plus 5. This is a linear polynomial of degree 1. Y plus root 2. This is a linear polynomial in the variable y of degree 1. X minus 2 by 11. This is again a linear polynomial in the variable x of degree 1. 3z plus 4. This is also a linear polynomial in the variable z of degree 1. And what about 2 by 3 u plus 1? This is also a linear polynomial in the variable u of degree 1, right? And earlier I said this cannot be called as polynomial. Why? Because the root is inside x. But here you look, this x, the root is only for root 3, right? It is written as root 3x plus 5. But here it is root x. If x is inside the root, that is not called as a polynomial. But this is an example of a linear polynomial. Now what about quadratic polynomial? A polynomial of degree 1 is called a linear polynomial. And if a polynomial is having degree 2, it is called a quadratic polynomial. So we studied what is degree of polynomial. What is degree of polynomial? If p of x is a polynomial in the variable x, then the highest power of x in p of x is called degree of the polynomial. In generally, right? In general. So what about the linear polynomial? A polynomial of degree 1 is called a linear polynomial, 4x plus 2. In general, ax plus b form. A polynomial of the form ax plus b is called a linear polynomial, right? It is having degree 1. And what about quadratic polynomial? It is having degree 2. And the word quadratic is derived from the word quadrate. Quadrate means square. This is just for your knowledge. Okay? Quadrate means square, and from this word quadratic comes. Now in general we can say that any quadratic polynomial in the variable x is of the form ax square plus bx plus c. So in the variable x, any polynomial, any quadratic polynomial will be of the form ax square plus bx plus c, and not that a is not equal to 0. That means the coefficient of x square is not equal to 0, and a, b, c are real numbers. Understood? So once again, quadratic polynomial, a polynomial of degree 2 is called a quadratic polynomial. Or generally we can say that it will be of the form ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. That means the coefficient of x square is not equal to 0. Now, the examples of quadratic polynomials are 2x square plus 3x minus 2 by 5. This is an example of a quadratic polynomial because it is a polynomial in the variable x having power 2. So, if it is of degree 2, then it is called quadratic polynomial, right? And what about this one, y square minus 2? Again, it is a polynomial in the variable y of degree 2. Since it is of degree 2, we can say that it is an example of a quadratic polynomial. Again, 2 minus x square plus root 3x. this can be rewritten as, you have to arrange it in this form, ax square plus bx plus c. That means x square term should come first. So here it is minus x square. So write it as minus x square. Then after bx. So here it is root 3x. Then constant term. What is the constant term? Plus 2. So this is of the form ax square plus bx plus c, right? So this is also an example of a quadratic polynomial, right? So this is an example of a quadratic polynomial having degree 2. The highest power in x is 2. So it is an example of a quadratic polynomial. And what about this one? This one is again an example of a quadratic polynomial. Why? Because it is having the power 2, right? In the variable u, it is having the highest power, that is 2. So we can say that it is an example of a quadratic polynomial. This can also be arranged in this form, ax square plus bx plus c. How? First you have to write the square term, that is minus 2u square plus u by 3 plus 5. And this is of the form ax square plus bx plus c, right? U by 3 means 1 by 3 into u, right? Okay, and what about this one? This one is also an example of a quadratic polynomial. It is having the variable b of degree 2. And what about this one? This is also an example of a quadratic polynomial. It is this polynomial is in the variable z of degree 2. So these are examples of quadratic polynomials. Why? Because they are of degree 2. So a polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 1 is called a linear polynomial. Linear polynomial is generally expressed as ax plus b form. And quadratic polynomial is represented as ax square plus bx plus c. Got it? Now, what is cubic polynomial? From the word cubic itself, we know that it is having degree 3. So, a polynomial of degree 3 is called a cubic polynomial. And the most general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and not that a not equal to 0. That means the coefficient of x cube is not equal to 0. Got it? So, the most general form of a linear polynomial is ax plus b, where a, b are real numbers and a is not equal to 0. And the general form of a linear polynomial, then quadratic polynomial. So, the most general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. And now, the cubic polynomial, its general form is ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a is not equal to 0. These are the general forms of a linear polynomial, quadratic polynomial and cubic polynomial. Not this, this is important. Okay. Now, the examples of cubic polynomial, we can consider these examples. Okay. What about x cube plus 1? In x cube plus 1, where is the x square term and x term? No terms of x square and x, right? Why? That means x cube plus 1 means we can write it as x cube plus 0x square plus 0x plus 1, right? Here x square and x terms are 0. So x cube plus 1 is an example of a cubic polynomial because it is a polynomial in the variable x of degree 3. So this is an example of a cubic polynomial. And what about 2 minus x cube? This can be written in the form ax cube plus bx square plus cx plus d, right? So this can be written as minus x cube. Here also x square term and x term are 0. So 0x square plus 0x plus 2. So this is again an example of a cubic polynomial of the form ax cube plus bx square plus cx plus d, and is having degree 3. So this is an example of a cubic polynomial. And what about x cube? This x cube means the other terms x square, x and constant terms are 0. So this can again be written in this form like x cube plus 0x square plus 0x plus 0. And this is having degree 3 and of the form ax cube plus bx square plus cx plus d, where b, c, d are 0. But a cannot be equal to 0 in this case. And here in quadratic polynomial, the coefficient of x square a cannot be equal to 0. And here a cannot be equal to 0. Understood? The other terms can be zeros. So examples of cubic polynomials are x cube plus 1, 2 minus x cube, the next example root 2x cube. Root 2x cube means root 2x cube plus the other terms are 0, 0x square plus 0x plus 0 This is also an example of a cubic polynomial because it is having degree 3 and is of the form ax cube plus bx square plus cx plus d, where b, c, d are zeros and a is not equal to 0. Its value is root. And what about this one? This is again an example of a cubic polynomial which can be written as x cube minus x square. Here x square term is there, its value is minus 1. But x term is not there. So 0x plus 3. This is again of the form ax cube plus bx square plus cx plus d, where the value of d is 3, c is 0, b is minus 1 and a is 1. And is having degree 3. So this is an example of a cubic polynomial. And what about the last one example? 3x cube minus 2x square plus x minus 1. This is of the form ax cube plus bx square plus cx plus d. That means a is equal to 3, b is equal to minus 2, c is equal to 1 and d is equal to minus 1. This is having degree 3 and is of the form ax cube plus bx square plus cx plus d. So these are examples of cubic polynomials. Now you got the terms degree of polynomial, linear polynomial, quadratic polynomial and cubic polynomial. What is degree of polynomial? Yes, let p of x be a polynomial in the variable x, then the highest order of x in p of x is called the degree of the polynomial. And what about linear polynomial? A polynomial of degree 1 is called a linear polynomial. Its general format is ax plus b where a not equal to 0. And what about quadratic polynomial? A polynomial of degree 2 is called quadratic polynomial and its general form is ax square plus bx plus c where a is not equal to 0. And what about cubic polynomial? A polynomial of degree 3 is called cubic polynomial and its general form is ax cube plus bx square plus cx plus d where a is not equal to 0. Understood? Now friends, consider this polynomial p of x is equal to x square minus 3x minus 4. Consider this equation or this polynomial. Here substituting, for example, I am substituting x is equal to 2. So that p of 2, because I am replacing x with 2, p of 2 is equal to, instead of x I can write 2, right? So 2 square minus 3 into 2 minus 4, right? That is 2 square, it is 4, minus 3 into 2 it is 6, minus 4, right? This plus 4 minus 4 get cancelled. I got the value as minus 6. That means the value minus 6 obtained by replacing x by 2 in x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 2. That is the value minus 6, right? We got the value minus 6 obtained by replacing x with k, x with not k, x with 2, right? So the value minus 6 obtained by replacing x by 2 in this equation, x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 2. Got it? Consider another example. If we are substituting x is equal to 0. First we substitute x as 2. Now second we are going to substitute x is equal to 0. So that p of 0 is equal to 0 square minus 3 into 0 minus 4. 0 square it is 0. Minus 3 into 0 again 0. The value is minus 4. So that we can say that the value minus 4 obtained by replacing x by 0 in this equation, x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 0. Got it? Again friends, first we substituted x as 2. So that we got the value minus 6. So we can say that the value minus 6 obtained by replacing x by 2 in x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 2. Similarly, if we put x as 0, then we will get the value as minus 4. That means the value minus 4 obtained by replacing x with 0 in x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 0. So in general, we can write like this: value of p of x at x is equal to k. That is, if p of x is a polynomial in the variable x and if k, small letter k, if k is any real number, then the value obtained by replacing x with the k, right? Then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. Understood? So value of p of x at x is equal to k. What is value of p of x at x is equal to k? If p of x is a polynomial in the variable x, and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k, and is denoted by p of k. See friends, let's do this question now, right? What is the value of p of x is equal to x square minus 3x minus 4 at x is equal to minus 1 and at x is equal to 4. That means if the question comes like this, you have to substitute instead of x minus 1 in the first case, and second case instead of x you can put x is equal to 4. So first case, if x is equal to minus 1, so that instead of x we can write p of minus 1. P of minus 1 is equal to minus 1 the whole square minus 3 into minus 1 minus 4, right? So minus 1 the whole square, it is plus 1. And here it is minus, here it is minus. Minus minus becomes plus in case of multiplication, right? So plus 3 into 1 it is 3 minus 4, right? So 3 plus 1 it is 4 minus 4. Plus 4 and minus 4 get cancelled. The answer is 0, right? And what about the next case? That is x is equal to 4. So we are substituting 4 instead of x. So p of 4 is equal to, instead of x we can substitute 4 square minus 3 into 4 minus 4, right? 4 square it is 16 minus 3 into 4 it is 12 minus 4. What about 16 minus 12? It is 4, right? Minus 4. 4 get cancelled. The answer is 0. That means if we put x is equal to minus 1 and x is equal to 4, the value of p of x is equal to 0. So now we can define what is 0 of a polynomial, right? So in general we can say that 0 of a polynomial p of x, that is a real number k, is said to be a 0 of a polynomial p of x if p of k is equal to 0. So what is 0 of a polynomial p of x? A real number k is said to be a 0 of a polynomial p of x if that real number p of k will be equal to 0. Understood? Now the question is, we studied how to find the 0 of a linear polynomial, right? For example, if k is a 0 of p of x is equal to 2x plus 3. This is an example of a linear polynomial because this is a polynomial of degree 1. And we studied how to find the 0 of this linear polynomial. How to find? The question is, if k is a 0 of p of x is equal to 2x plus 3. That means k is 0 in this polynomial, right? So instead of x we can substitute k. P of k is equal to 2k plus 3, and it is given that it is a 0 in this polynomial. That means which is equal to 0. That is 2k plus 3 is equal to 0 implies 2k is equal to minus 3. Implies k is equal to minus 3 by 2. So what is the value of k? Minus 3 by 2 or minus 1.5. So understood what is 0 of a polynomial? 0 of a polynomial, a real number k is said to be a 0 of a polynomial p of x if p of k is equal to 0. If p of k is equal to 0 for any real number k, then it is said to be a 0 of a polynomial p of x, right? Now example, this is an example of a 0 of a linear polynomial. We know how to find the 0 of a linear polynomial because we studied in class 9, right? So it is given that if we put k instead of x, we will get the value 0, right? So p of k is equal to 2k plus 3 because we are substituting k instead of x, and it is equal to 0. It is given that k is 0, p of x is equal to 2x plus 3. And now substituting we will get the value of k as minus 3 by 2. So how we can generally define 0 of a linear polynomial? This is the case of a 0 of a polynomial in general form for all the polynomials. 0 of a polynomial p of x. Here particularly 0 of a linear polynomial, how we can define it? If k is 0 of p of x is equal to ax plus b, because in case of linear polynomial it is of the form ax plus b, right? So if the polynomial ax plus b and if k is a 0 of that polynomial, then p of k is equal to 0. That means p of k it is ak plus b. Instead of x we are substituting k, right? So p of k equal to ak plus b, which is equal to 0. From here we will get k is equal to minus b by a, right? We are defining 0 of a linear polynomial, right? So 0 of a linear polynomial, if k is a 0 of a linear polynomial, p of x is equal to ax plus b, then p of k is equal to substituting k instead of x. So p of k is equal to ak plus b, and it is given that it is a 0 of P of x. So it is equal to 0. From here we will get the value of k, which is equal to minus b by a. And we know the general form of a linear polynomial, it is ax plus b, right? So minus b by a means b is the constant term, right? So minus b by a means minus of constant term divided by a is the coefficient of x. Got it? A is the coefficient. This is in case of a linear polynomial. B is constant term and a is the coefficient of x. So we can say that 0 of a linear polynomial is related to coefficient of x. Got it? So 0 of a linear polynomial is always related to its coefficient of x. That is minus b by a. So how to find the 0 of a linear polynomial using this formula, minus b by a, which is nothing but minus of constant term divided by coefficient of x. Now friends, we can revise what all things we have studied in today's class. So we discussed what is degree of a polynomial p of x, right? So if p of x is a polynomial in x, the highest power of x in p of x is called degree of a polynomial p of x, right? And what about, there are three types of polynomials we are going to study. Linear polynomial we already studied in class 9, right? So a polynomial of degree 1 is called a linear polynomial. Example 3z plus 4, right? And there are so many examples we discussed. This is one such example. And the general format of linear polynomial is ax plus b, where a not equal to 0. And a polynomial of degree 2 is called a quadratic polynomial, and its general form is ax square plus bx plus c, where a not equal to 0. An example of a quadratic polynomial is 2x square plus 3x minus 2 by 5. And cubic polynomial, a polynomial of degree 3 is called a cubic polynomial, and its general format is ax cube plus bx square plus cx plus d, where a not equal to 0. And example of a cubic polynomial is 3x cube minus 2x square plus x minus 1. Then we discussed value of p of x at x is equal to k, right? If p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to k and is denoted by p of k. That is value of p of x at x is equal to k. Now 0 of a polynomial p of x, a real number k is said to be a 0 of a polynomial p of x if p of k is equal to 0. And what about 0 of a linear polynomial? If k is a 0 of p of x is equal to ax plus b, because ax plus b is an example of a linear polynomial. Its general format, the general form of linear polynomial is ax plus b. So if k is a 0 of p of x is equal to ax plus b, then p of k is equal to substituting x by k, right? So p of k is equal to ak plus b, and it is given that equal to 0. So that we will get the value of k is equal to minus b by a. And what is minus b by a in case of a linear polynomial? Minus of b is constant term divided by a is the coefficient of x. So we can find the 0 of a linear polynomial by using this formula, that is k is equal to minus b by a, which is minus of constant term divided by coefficient of x. Friends, now we are going to wind up the class. I really wanted to continue the topic till exercise 2.1. But if I do so, the video would be more lengthy. So in order to avoid that, I am stopping with this. That is 0 of a linear polynomial. We will continue the rest in the upcoming videos. So if you like my videos, subscribe the channel, share with your friends, and press the bell icon to get notification of my latest videos. See you in the next video. Till then, have a good day and thank you.